expression of electric field electric field at a distance y at a distance y on the broad end side on the broad end side due to a due to a due to an infinite wire. Suppose the infinite wire lies along the x-axis, lies along the x-axis, the x-axis. The electric field at a distance y from the wire, electric field at a distance y from the wire needs to be calculated. Now see this. This is your x-axis, and this is your y-axis. This is your y-axis. Let me call this y-axis, and this is your x-axis. Consider an elementary length of the wire, suppose dx on this side. Similarly, you consider dx on this side. Now at this point y, this is at a distance y from the wire, center of the wire. Now the electric field due to this part, now this is at a distance x. Consider the elementary at a distance x. So this is under root x square plus y square by Pythagoras theorem. This is making an angle theta. So the electric field will be in this direction. This way. So this is theta. So this is theta. Similarly, for this side, you will have this is theta. This is at a distance x, and this is y. So this will be again x square plus y square, and the electric field in this direction will be on this part. Let us say this is dE2 vector and this is dE1 vector. Now this is vertically opposite. So this is again theta. So now you see. So let us write down. Consider an elementary length dx of the wire. Now the electric field or due to dx on the right side of the wire, on the right side, that is this side, due to dx, now the electric field due to on the the electric field due to dx on the wire at point P. This is the point P. At point P is dE1 vector. Now see one thing. Now the length, this, let me write out here something. The length, the elementary length dx is at a distance x from the center of the wire, from the origin. This is the origin. Is at a distance x from the origin. I forgot to write this, from the origin. Now dE1. Now dE1 will have dE. Now this will be, now see, there will be cos theta component and a sin theta component. dE1 sin theta minus I cap, because this will be the positive direction of I cap is this. This is on this direction. dE1 is here. dE1 sin theta is in this sense. and plus dE1 cos theta j. This is the thing. Now, similarly, the electric field, electric field field due to the element dx at the left of the wire, left rather on the left of the wire, electric field to the element on the left of the wire, on the left of the wire of the wire at point P is this very point P is dE2 vector. Now if you see this figure, dE2 will again have two components. dE2 will again have two components. One is in this side. Let me put a different color. This will be dE2 cos the sin theta component, and there will be here will be the cos theta component. Similarly, for this, there will be a cos theta component in this sense. So now you can see dE2 vector is nothing but dE2 sin theta I cap plus dE2 cos theta j cap. Now see one thing. This is 2. This is 2. Now dE1 numerically is equal to dE2 numerically, which is nothing but 1 by 4 pi epsilon naught. You can say lambda dl uh, upon this your x square plus y square. This is the thing. Now see, because this lambda dl is nothing but dq, and lambda is the charge per unit length. Lambda is charge per unit length of the wire. Lambda is the charge per unit length of the wire. So dl, or you may write dx, no problem. That's your choice. You may write dl or dx, that's your choice. Lambda is charge per unit length of the wire. Charge per unit length of the wire. Unit length of the wire. Now the point is the net electric field at P. Net electric field at point P. Point P is dE vector. That is nothing but dE1 vector plus dE2 vector. Now, if you write dE1 vector, that is nothing but, see, dE magnitudinally they are all same. Magnitude they are all same. You can write them as dE, no problem, the way I did earlier. dE sin theta minus I cap plus dE cos theta j cap. This is for this part, and for this part it is dE cos theta I cap plus dE sin theta j cap for this part. Now both the magnitudes are same, so numerically they cancel out. This and this not this, but this component cancels out. The sign components cancel out. What you are left is also you can write it this way also. If you take this figure completely, now this component, or that is the dE, the sin theta component, and the dE sin theta component of this and this cancels out. The x-axis components cancels out. Only the y-axis component will add up. That is, only the j components will be there. Only j component will be there. So dE is equal to dE 2dE cos theta j component. Now dE vector is equal to 2 into 1 by 4 pi epsilon naught lambda dl upon x square plus y square cos theta j vector. Now dl in this case here dl is equal to dx. Why? Because I'm taking along the x-axis. Now the thing is this. See here. Now see here. Now therefore dE is equal to 2 into 1 by 4 pi epsilon naught lambda dx upon x square plus y square cos theta j cap. Now here there is something that I like to know. If you integrate, to take the integration e, you need to take it 2 into 1 by 4 pi epsilon naught, to take it outside. You take the lambda outside and integrate from 0 to infinity dx x square plus y square cos theta j cap. Now you will have to integrate from 0 to infinity and not from minus infinity to infinity, from minus infinity to infinity. Why? Because you have taken the full length, you have taken the contribution from this side also, you have taken the contribution from this side also. If you take minus infinity to infinity, it will be double counting. So to avoid that, you have to take 0 to infinity. You have to take 0 to infinity only, the positive part, that would do the job. Now you see one thing. I hope you understand why you have taken from 0 to infinity. Now if you see that figure, this was y, this was x, this was the elementary length dx, here it was, elementary length dx was here, this point, this is theta, so your tan theta is, tan theta is y upon x. Now you see x is equal to, x upon y, not y upon x, but x upon y. It is x upon y, so x is equal to y tan theta, so dx equal to dy sec square theta d theta. See why I have taken theta as the variable and not x. Now see, the further you go, if you see the figure, the further you go from this point, you go this side, the theta changes. This theta will change. That's why I taken the variable as theta here, not x, because theta will help me to do the calculations faster. Now see, now if you write E vector, this E vector is 2 into lambda by 4 pi epsilon naught. Now you put, in place of dx, you put this. Sorry, not y. This is y, not dy. So by mistake I've written it. This is y. So now, if you write this, in place of x, if you write, this is at x0, theta is 0. At x0 and at x equal to infinity, at tan infinity, that means pi by 2. This will become pi by 2. Because if you put x equal to 0, then theta is 0. See, at x0, theta 0. At x infinity, theta is pi by 2. You put pi by 2 here, tan pi by 2 is infinity. So at infinity, at x equal to infinity, theta is pi by 2. Now dx is y sec square d theta sec square theta d theta into, you have cos theta here, no problem. Then you have put the value of x. You have this as, you can see, you put it, x is y square tan square theta plus y square, and you have j cap. Now take y square common out. Take y square out. If you take that y square out, now you see one thing, E is equal to 2 into lambda 4 pi epsilon naught. Now this y will come out, from here y square will come out, and then you have 0 to pi by 2, you have sec square theta upon tan square theta plus 1 into cos theta d theta j cap. Now tan square theta plus 1 is sec square theta. Tan square, you already know, tan square theta plus 1 is equal to sec square theta. Wait a minute, let me write it. Some more space. Tan square theta plus 1 is equal to sec square theta. So here the vector form. So now you have this. E is equal to 2 into, this is into 2 lambda y. This y and this y cancels out. You can forget this y here. So this 2 and let this 2 cancel out. So what you are left with, lambda 2 pi epsilon naught y. Now you have this as 0 to pi by 2. This is sec square theta upon sec square theta cos theta d theta j cap. Cancel these two. What you are left with, cos theta, and the integration of cos theta is nothing but sin theta. So lambda 2 pi epsilon naught y 0 to pi by 2 sorry, sine theta, not the integration of cos theta is sine theta. So sine theta 0 to pi by 2, if you put the upper limit minus and j cap, and you have this as epsilon naught, this is epsilon naught. So E comes out to be electric field lambda upon 2 by epsilon naught y, then this comes out to be sine pi by 2 minus sine 0, and this is j, sine pi by 2 means sine 90, that is 1. So E comes out to be lambda upon 2 by epsilon naught y j cap. Now the thing is this, if I take a wire, I have taken an infinite wire. Suppose the wire has a length, say, the wire has a length, say, L. Suppose for a finite wire, suppose for a finite wire of length L, I have to take, see, I have to take this point as 0, this point as y, I'll take this much part as L by 2, I'll take this part as L by 2, I'll take in the midpoint. The total length is L. So in this case, if you see, this expression is independent. This expression is basically, if you take this, now you try to solve it in the same manner. Now to solve it in the same manner, now instead of, if you see this, this portion, I'm talking about this portion. If you look at this portion, this one portion, this much portion here. Now this will be from 0 to, sorry, now it will be from 0 to L by 2. See, I took from here, see, I took from 0 to pi infinity. I took here from 0 to infinity. Now I will take from 0 to L by 2. Now I will take this from 0 to L by 2. See what happens. In this case, now electric field in this case would be lambda upon 2 pi epsilon naught. See, 0 to L by 2. You have dx cos theta. Then you have x square plus y square. And then you have this y here, j cap. Now you have to take again x equal to tan y tan theta, no problem. Now you see one thing, if you take this tan theta, so tan theta is nothing but x upon y. Fine, tan theta is nothing but x upon y. Now, if tan theta is x upon y, so theta is tan inverse x upon y. Now, a little bit of mathematics is needed here. This x upon y. Fine. Now, you can see here, this is your x, this is your y, and this is your theta. This is under root x square plus y square by Pythagoras. So if you see sine theta is what? This upon this. So sine theta is x upon under root of x square plus y square. So from here, theta is sine inverse x upon under root x square plus y square. This is needed. So theta is this and theta is this. So both of these two are same. This expression and this expression are same because the theta is same here. Now you see one thing. Now we will keep this here at x0. At x0, theta is straight away 0. Now x equal to L by 2. At x L by 2, put here theta. At x L by 2, see what happens. Theta is equal to sine inverse. Why did I take sine? I'll tell you why. You will see in a minute. This is L by 2. This is L square by 4 plus y square under root. Nothing of this sort. So if you take the expression again, you solve this expression again, take this as 4 as LCM. If you take the 4 as LCM, then you have this as sine inverse L by 2, and then you have 2 outside, 1 by 2 outside, sorry, 1 by 2 outside, 1 by 2 outside, 1 by 2 outside under root L square plus 4y square. This you will get. L square plus 4y square. This half and this half will cancel out. This sine inverse would be L upon under root L square plus 4y square. This is very, very important for you to understand. Now, why I took sine square, sine inverse, I'll tell you right now. See, our expression was this. This was our expression. Now, if this is our expression, now what I do is that I put in place of x. See, let us do it here. We have E. So dx will be equal to y sec square theta d theta. So E is lambda upon 2 pi epsilon naught. Now you have 0 at this. Now you put this at C. At x0 it is this. At xl by 2 it is sine inverse L under root L square plus 4y square. Now you see sine inverse L upon under root L square by 4y square. This whole part is different. This part is all different. Let me mark it this way. Now you have y you have y dx is yes you have this as dx is y sine inverse. Let me see the expression once more. This is y dx. Which is y dx. Yes, let's check once more. Yes, it was dx. Okay, not y dx. So just a minute. Yes, it was dx, not y dx. Sorry. So now you have this expression now. In this, you will not have y anymore. Y you will not have. Sorry. This will be dx. This will be instead of dx, you will write y sec square theta d theta cos theta j cap upon, you take y square out. You take y square out. You have tan square theta plus 1, and they two cancel out each other. So now you have, see, you have E vector is equal to lambda upon 2 pi epsilon naught into 1 upon y, 0 to sine inverse L upon under root L square plus 4y square is 4y square cos theta d theta j cap. And this comes out to be, very simply, this comes out to be E equal to lambda upon 2 pi epsilon naught y cos theta is sine theta of 0 to sine inverse. That's why I took, because sine and sine, this sine will cancel each other out. That's why I took sine inverse. Now I hope you have understood why I have taken sine inverse. Y square. So taking the upper and the lower limit, sine 0 will be 0 with a j cap here. The j cap here. So your electric field would be, so the electric field is lambda 2 pi epsilon naught y. Sines and sine inverse will cancel. You have into L into under root L square plus 4y square. Now you see j cap. Now lambda is what? Charge per unit length. The length is L. Just put this L here. E equal to lambda. Instead of lambda, you put this Q. Total charge Q 2 pi epsilon naught y. You take this L here into L upon under root your L square plus 4y square. Now you have this. Now if this is the thing, now here, wait a minute, this is the thing, this is j cap, you can cancel this L. What you are left with? Now what we are left with, E you are left with Q upon 2 pi epsilon naught y into under root of L square plus 4y square j cap. Now you want to, suppose, get back the case for L tending to infinity. What you do is that you take out L out. Suppose after finding this, what happens if the other way around, L goes to infinity. If L goes to infinity, do one thing. In this expression, take L out. E equal to Q upon 2 pi epsilon naught y L and then under root 1 plus 4y square L square j cap. Now Q by L is nothing but lambda. This is lambda. Q by L is nothing but lambda. Lambda upon 2 pi epsilon naught. Okay, and then L goes to infinity. This quantity will go to 0. So this will be y j cap. So E is basically this. What I have done, first I found out the expression for infinite case, and then I found out the case for finite. And in the case of finite, I took the infinite case as a special case. Then you can get this directly. Instead of doing that, You can do the finite case and take L tending to infinity to get the infinite case.